I was clicking on this, so welcome everyone. I am Mirjam. I work for FHIR, as you can see maybe by my yellow shirt. FHIR is not only an event organizer, we don't only organize this DevDays, but we also do have tooling around the FHIR specification. We have consultants, we have trainers, and I'm one of the trainers at FHIR. So whatever you need with FHIR, come to us. And well. What we are going to do in this session is look why we need profiling, and then I will explain what the parts are of the FHIR conformance layer so you can do some profiling. We're not actually going to profile in this session because it will just give you an overview of the possibilities. But I'm always happy if you have any questions afterwards. Of course, we'll try to answer questions after this presentation, but also do walk up to me if you're in person here and ask me to demo something or show you something. I will be happy to try and help you out with things. And of course, I have other colleagues that can do that as well. So we'll start with that. We'll talk about implementation guides and mainly, of course, profiles and extensions. So first of all, why would we need to do some profiling? We know that we have the FHIR core specification, right? We have these building blocks in the form of FHIR resources. But we also know that whenever you look at healthcare, your context may be different from another context that you know of. So you may have some extra requirements that are not covered by the base resources because the standard, the FHIR standard, needs to cover all kinds of contexts and use cases in healthcare. So it needs to be flexible enough for that, but then you may need to specify some extra requirements you have. So for that, FHIR has chosen to create a conformance layer with FHIR resources so you can specify those extra requirements. So that's what we are going to take a look at. What's nice about that, since we have those FHIR resource types that are part of the conformance layer, we are able to author all of our extra requirements in those resources. So they are authored in a structured way. And structures, they can be published so other people can find them if you publish them on a public repository, for example. Oh, no. So part of the FHIR conformance layer is that set of FHIR resource types. And I have a couple of them, or the most important ones, listed on this slide. You can see we have things that have to do with the content, so the FHIR resources and data types that we have, the data actually that we put in. But you also have things like terminology type resources to make sure that you can work with the sets of codes that you need. We can also look at things that have to do with interactions or operations on the FHIR specification and some miscellaneous other ones. For the most important ones that you will encounter first, I have a couple of slides to explain those. So first of all, the structure definition. I think that's the first one that you will encounter the need for. The structure, as the name says. So it defines data types, it defines resources, and that is done for the FHIR specification itself as well. So if you look at one of the FHIR resources, the base resources, there will always be a structure definition behind that that defines that particular model that you're looking at. We can also use structure definitions to create our own constraints, our own extra requirements that we have. And also, you may find the need for extensions. I will go into that a little bit deeper in a bit so you know what extensions are. But you will probably need some, and also for those, structure definitions be used. Another important one has to do with terminologies. Quite often in your own use cases, you have a list of codes that are applicable for that use case or that project. And then you may want to specify that list, and that's done with a value set resource. So you can specify exactly the list of codes coming from a code system. So a value set will always point back to a code system that the codes come from, or even a combination of code systems that you take your codes from. And then that will be your value set, your set of codes relevant for your use case or project. And what you can do then is in your FHIR model, in your structure, you can actually specify that this particular field needs to take a code from that particular value set that you've created. So you can bind that value set to a field, an element inside of your FHIR resource. Then I also mentioned search parameter or operation types of conformance resources. Well, search parameter Okay. So I think that there are some problems with see that used when people actually mean the whole implementation guide or a package of those conformance resources. This slide shows you the layered profiles. So, of course, we have a set of core profiles. There are structure definitions for the FHIR core. Then from that, you could have maybe a nationally scoped project with national profiles. And you can even divide that into regional profiles if you want to. In the end, organizational profiles or more project-specific, use case-specific profiles will be there. All of the resources, of course, need to always conform to the FHIR core. So whatever you do in your profiles can only restrict further down the data. You cannot make the data in FHIR more lenient because you would want to be FHIR valid. So the canonical URL for a structure definition is a mandatory field. You would want to think about that. It is the form of a URL, as I mentioned already. You want to start with a domain part that you have a claim to. So your organization, you don't start with hl7.org because you're probably not hl7, right? So think about what a correct domain part would be for that. And then it's up to you to think about the naming convention. In the metadata of a structure definition, you can specify further details like who's responsible, who to contact, etc. Copyright information, that's all part of the metadata of the structure definition. Then inside the structure definition, you will see that there is a list of element definitions. Element definitions, elements are the fields inside of a FHIR resource or data type. So an element definition defines exactly that field. Now, of course, that's already present in the core structure. But what you can then do is constrain the cardinality. And that will end up in an element definition that is the differential from the base definition that you have based yourselves on. So that will end up in your structure definition part, what the differences you have made to that base profile. Well, you can do other things as well, fill in terminology bindings, as I mentioned, etc. And in the end, you get something that looks like this. We can add extensions, we can limit cardinalities, we can limit the choices for certain choice property fields. We can even forbid elements to be on the data, but we want to author that with care because the more you forbid, the less flexible you will be. And you can also always ignore optional data, right? That's also always a possibility. So my choice would be to ignore incoming data that is not needed for a project, but it's possible to specify that you actually really do not allow that data to be present on the set. As mentioned, you cannot go against the core specification, so you can only limit down the optional elements to be not present. When you have a list of things, a 0 to star field, you can limit it down to a 0 to 3 field if you want to, so limiting to just 3 elements. And you can make optional elements mandatory, but you cannot make mandatory elements optional. Extensions is also something that you will encounter. They will lead to structure definition resources, so that's why they are in this section of my presentation. Extensions allow you to extend existing data with a data element that is not present in the core specification. In the core, you will have the work groups looking at an 80-20 rule. Maybe that has been mentioned already. If something is implemented in 80% of implementations, they will put it in the FHIR core specification. If not, you're out of luck. It will not be in your FHIR resource. But you may still need it for your own project. Maybe it's an important element for you, even though internationally it's not in 80% of implementations. So that's where extensions come in. You want to, in a way that FHIR can accept, extend the data with some extras that you need for your project. Some things are illegal in one country and need to be there in another. So that's the example here. Right away, you can see that is an element for, in this case, the registration of race or ethnicity, which is something they cannot put in the core specification. It's not viable to look at that and implement that in a lot of countries. So for that, you will need to have extensions. So as I mentioned, an extension leads to a structure definition resource, and you will have to give it a canonical URL again as well. When people then use your extension, they will actually add that URL in the data. So in the data itself, if you get a patient in, there will be an extension field on the data, or can be, and then that extension field will have the URL to point to the definition. So the receiver will be able to look up the definition and see what was meant with this particular extension. That's, of course, why it's important to be able to publish your definitions as well, so other people can look up those things. In the definition, it will also tell you where can this extension be put on the data. Some extensions can just be put on the top level of a FHIR resource. Others go further down into the FHIR hierarchy and, for example, are valid on the patient's birth date field. So that's all possible. When creating extensions, we do recommend to make them as generic as possible for possible reuse within your own organization or other organizations as well, if applicable. So on your structures, on your profiles, you can specify things around cardinalities, terminology bindings. We can now add extensions to that as well. Sometimes you have the need for some extra requirement that you cannot actually formulate with just type restrictions and constraints on the cardinality. For that, you will have complex constraints. With complex constraints, you can add an expression to your profile, and that expression is supposed to be a FHIR path expression. With that, a validator that is FHIR path aware can check whether that expression is true. And if not, of course, the data will not be valid. So if it violates that particular expression, the data is not valid. You will see those kind of complex constraints in the core FHIR specification. So the example that I have on here is taken from the core spec, where I've looked at the bundle resource type, and that has an extra rule that says if the type of this bundle is set to document, which is one of the possible bundle types, then that implies that the timestamp field has a value. That's what you can read here. You can see it's actually kind of readable. So those kind of extra constraints can be set with FHIR path expressions, complex constraints. There is a FHIR path session done by Brian Postlethwaite, and he is going to do that on Wednesday. So if you're interested in actually trying to build those expressions, take a look at his presentation. It's a Let's Build session, so it's only available in person here in Amsterdam. But it's definitely interesting to see what you can do with those expressions. Here's an example of a profile. So with the base definition of the patient plus the extra requirements that are set, you can get a view like this, where you can see some extensions have been added. Some fields have been made mandatory, actually, like the identifier and the name. If you look at the core specification, it's an optional field, so it's a 0 cardinality as minimum. And what you can also see here is a red S saying this is a must support field. As a profile author, you can indicate that fields are important with that must support field. And then in your implementation guidance around this, you should specify how this field has to be supported in implementations. But that's another thing that you can do. It's a more of an implementation hint. Look at this field, make sure that you have looked at it, how to implement support for that. In the data, you can refer to profiles. So I have an example here where I have an observation, a cholesterol type observation with a value inside. And I could have a profile URL filled in the meta profile field. In this case, that meta profile field can say, hey, I'm conforming to the acme.org FHIR profile for LDL cholesterol. This is just a claim if it's on the data. It's not mandatory to have it on the data, but if it's on the data, it's a claim. So if I get this data in, I might want to try and see if that's actually valid, right? So what I can do is take that URL and I can reach out to the acme.org FHIR server to see if it can give me the structure definition for that profile that they have. Well, in this case, maybe the acme.org FHIR server is there and gives me that structure definition, in which case I can progress and I can do that validation step. But as I just mentioned, that canonical URL does not have to be resolvable. And we do not really expect everyone to have some kind of a FHIR server up and running 24/7 just to be able to serve up those structures, value sets, and other conformance resources. So another option that you would have is look at a registry. And a little bit of a plug here, the simplifier.net platform developed by FHIR is a public repository for FHIR conformance resources. Everyone can search that platform. You don't have to have an account. If you want to publish anything on there, you would want to have an account to be able to create a project. But that could be a go-to. See if Simplifier has that structure or value set or other conformance resource by searching on the canonical URL or just by searching for some keywords and finding relevant profiles and extensions. So that brings me to a registry. And there's a slide around tooling as well. There is an official HL7 registry for profiles, registry.fhir.org, and also one for implementation guides. When you want to be taken up into that implementation guide one, the second link, fhir.org/guide/registry, then you would need to go through a quality control check and balloting, etc. So you would have to have a ballotable implementation guide when you want to be taken up in there. That registry.fhir.org for conformance resources, that is actually powered by Simplifier. So I've already mentioned Simplifier. You can create a project there, and then you can opt in to be shown on the FHIR registry as well. What this doesn't mention is that you can also find packages on Simplifier. There is an HL7 package feed and several other package feeds that are monitored. Simplifier picks up on those as well. So whenever someone publishes a package of their conformance resources through one of the official registered package feeds, then they will end up on Simplifier as well. So that's, again, what you can use for looking up to see what the package is. As mentioned, it's the backend for the registry, and you can create as well as download or browse packages on Simplifier, and some other options are on there as well. Well, if you're interested in that, I would be happy to give you a quick demo, but that's later on after this session has ended. You may also want to be able to create those structures and other conformance resources. We do have a Forge tool, which is created by FHIR again, which is a profile editor. This is one of the profile editors out there, and it's quite feature complete. So you can actually create that. It's a nice user interface where you can click on some buttons and then out comes your profile. I will say this. For me, you don't have to use the Forge tool, of course. You can also take a look at FHIR shorthand if you want, which is a grammar to be able to create your profiles and extensions. Perfectly okay, but whatever you do, don't create a structure definition by hand. Always do use tooling. And Gino agrees with me on that, I think. It's very, very easy to make mistakes in the actual way that you set up the structure. So leave that to tooling. You may want to take a look at an XML or JSON structure definition resource just for fun for some time. You don't actually want to really interpret that with your human eyes. Again, those structures, they are more for tooling than they are meant for human eyes. So yeah, do take a quick look, just get a feel of it, and then forget that and work with the tooling around that. So for tools, I mentioned our Forge tool and Simplifier, but you actually also, and I have some options on here, want to maybe take a look at FHIR shorthand. There is an actual tutorial, Learn to Fish, FHIR shorthand fish. And that will be, I think, right after this one, or at least this afternoon. So if you're interested in actually creating some profiles, do take a look at that particular presentation. There are other presentations around profiling, conformance resources, etc. as well as some community talks talking about how they've used an implementation guide or all kinds of things around that. So I've just noted a couple of them on this slide. You will be able to find that in the PDF that is in the Whova app as well. My presentation should be uploaded there. So do take a look. And well, that's actually it for my presentation. Are there any questions?
Thanks, Mirjam. For everyone online, we'll be taking questions first here. And then after that, if there's still questions online, we'll be looking at Whova. So are there any questions here in the room?
Thanks. Hi, thank you very much for your presentation. I love your enthusiasm. Thing is, I'm currently mapping or profiling our relational database model to FHIR, especially medication. And what I'm always encountering are like data fields where I never know to which field, following the FHIR resources that are available. Should I map it or should I build an extension because I don't find it anywhere? Now the question is, how should we, or what help can you provide, or mental help can you provide, how to proceed to figure out if I have to make an extension or search anywhere else?
That's a good question. Thank you. So mapping is always difficult, right? So if you look at your own data, you will, and you want to map that to FHIR, you will always encounter some data elements in your own data that are not nicely mappable to the FHIR resource that you've chosen to map to. Well, the first step actually is to choose the right resource type already. So that could be a problem. Sometimes it needs to be in multiple resource types. So that could be a thing. I would definitely take a little bit of common sense, not create too many extensions. But first of all, I would take a look at what's there on a national level or on a regional level already as maybe a profile set that could be relevant to you. Or maybe there's already a project going on a more international scope that could be helpful for those kind of things. See how they've done it. Maybe you can use their profiles and extensions already without having to do much extra work yourselves, or it could function as an inspiration for what you could do in your own work as well. Another thing that I would recommend is to go to chat.fhir.org. That's the FHIR community platform. Just present your problem there. Present some ideas that you have and get a little bit of a sense in the FHIR community to see if you're on the right track. Because there will be a lot of people that may have already run into something similar and have had some ideas, or can just stop you from creating tons of extensions. Just say, okay, well, we probably would want to limit it to this or that. Do you really need that extension, etc.? So that would be my recommendation. Look at the nationally scoped things first. Maybe look at the core extensions that are there as well, plus go to the FHIR community and just reach out to them. They're really happy to help. That's a nice set of people. So I welcome you to that community as well.
Good. Any more questions? No? Let's check online. There's a question. How do you specify the behavior of an operation definition?
There is some description that you could put inside of the operation definitions text. But next to that, what you will do in the operation definition is you will specify on what level that operation can be called. It can be on a resource instance, on a resource type level, or even system-wide operation. So that will already help a little bit. But in the description, definitely, and plus your implementation guide, give extra guidance, give maybe some examples of calls. With the input and output parameters, of course, it's already clear what is expected as input and output of the operation, but extra guidance in an implementation guide around that could help the developer even further.
And we don't have an executable. There's no executable.
No, there's no executable way of describing the behavior. So documentation.
Thank you. Another question here is perhaps they missed it, but could we get an overview of a complex extension and how they differ from extensions?
Okay, they did not miss the complex extensions. I did not mention them. A simple extension is where you, as an author, define a URL and what kind of value can be used in that extension. So a simple URL value combination. A complex extension, instead of the value, you will have sub-extensions. Per sub-extension, you define a URL again, which actually would be a simple string because it's relative to the parent URL, plus a value again. And the value can be any of the FHIR data types. If you want, you can even make it more complex, but in reality, I have never seen complex extensions that go more than 2 levels deep. And if you decide upon such a structure, I would definitely reach out to the FHIR community and say, hey, I've invented a new data type or new structure, help me out here, because then you're actually trying to model something that's not supposed to be an extension, probably.
Thank you. No more questions in the room? All right.
Well, thank you so much then. Thank you, Martin, for moderating for me. I wish you a good rest of your Dev Days and thank you for being here in my presentation.